Okay, hi everybody. Today we are going to be doing section 7.3, the first half of it. And what this one is about is solving equations where variables show up on both sides. Up to this point, we've had variables that only show up on either the left side or the right side of an equal sign. Now we are going to be looking at equations where the variables show up on both sides. You will see what we are talking about in just a couple of minutes. Okay, so let's get right into the do now. Once again, I suggest that you stop the video right now, you try to answer these on your own, and then you continue to see how you did. All right, and we're back. All right, so for number one, we have to get the variable by itself, which means we undo the operations that have been done to the variable. Right now we have x take away 4. We undo the minus 4 by adding 4. And what I do to one side, I must do to the other side. 4 plus 4 equals 0. So I can just cross that out. I get x equals negative 13 plus 4 if you use a number line, or if you just know it by this point, you get negative 9. And we're done. All right. Number two, we have 8 plus z. Okay, and what we have right now is we have this z here with an 8 added to it. Okay, normally we would write z plus 8, that's how we've seen it a lot, but there's nothing wrong with saying 8 plus z, it means the same thing. We still have to get rid of the z, we still have to get rid of the 8, and the way we do that is by subtracting 8 from both sides. I am left with positive z. I'm left with positive z, and that is just z. So z equals negative 15 minus 8, which is 7. Okay, we're done. Okay, number 3, we have 3 minus L equals negative 2. Once again, I'm going to try to get rid of the numbers around my variable to get my variable by itself. There's a slight difference here, though. So what we are going to do, we're going to take away 3 from both sides. Minus 3, I get negative 5 on the right, and this equals, be very careful, because what I actually have here is a negative L, minus L. Okay? You cannot forget that negative sign. So we're not done yet. We know that negative L is equal to negative 5, and then we can do a couple of different things. We can say, well, if negative L equals negative 5, then L must equal 5. Or we could multiply both sides by negative 1, which would give us L equals 5. Or we could divide both sides by negative 1. Divided by negative 1, divide by negative 1. Negative L divided by negative 1 is L. Negative 5 divided by negative 1 is 5. Anyway, any one of these will give us the right answer, L equals 5. And then finally, number 4. Negative 5 minus k equals negative 1. What I can do here is undo the operations one at a time around the variable. So the opposite of negative 5 is plus 5, so I add 5 to both sides. Add 5 to both sides. I get negative k, again, don't forget the negative sign, negative k equals 4. Negative 1 plus 5 is 4. And then I will, right now I will divide both sides by negative 1. Negative k divided by negative 1 is k. 4 divided by negative 1 is negative 4. And there's my answer. For those of you who are curious, I could have done the exact same thing, or got the exact same answer by doing this instead. Negative 5 minus k equals negative 1. I will just multiply every term by negative 1. We've already seen that you can do the same thing to every term as you would like to. And what this would give me, instead of negative 5 minus k equals negative 1, a lot of negatives, everything would be positive. I'd get 5 plus k equals 1, and that might be a little bit easier to solve. Let's just check it real quick. Minus 5, k equals negative 4. I get the same thing. Okay? So that might be a little bit easier. You can, if you see a whole bunch of negatives, you can multiply everything by negative 1, and all of the terms that were negative would become positive, all of the terms that were positive would become negative. Okay? Let's go on to number 5. Negative 3g, or this is just telling me to simplify here. So negative 3g plus 5g, just a quick reminder, that gives me 2g. And negative 7y minus negative 4. Negative 7 minus 4 is going to give me negative 11y. If you do not believe either of these last two answers, I invite you to use a number line and convince yourself that negative 3 plus 5 is 2, and negative 7 minus 4 is negative 11. We are moving on with the lesson, however. Okay. 1. The first thing we're going to do is when variables show up on both sides very easily, okay, and what I have here is, unlike what we have done in the past, I have a variable over here and a variable over here. Let's highlight that. Right there I have 2a on one side and the same variable on the other side of my equal sign. And this is, remember, this is the most important part of an equation, the equal sign. Okay? And what we are saying here is that variables show up on both sides. Now, we don't like that because at the end we want to say something like a, or let's not do that permanent because I'm just making an example. Let's say the answer turned out to be 1. We want to be able to say a equals 1 at the end. Okay? Notice, at the end, we only want the variable on the one side, not on both sides. So we have to fix this. Turns out that it's actually very easy to fix, just like what we've been doing, if you're careful. Remember, you cannot do something like this. I'll do it in red to show you that it is not acceptable. You cannot do something like this, 2a minus 2, or 3a minus 3. Those are not things that are okay, because 2a minus 2, these are not like terms. So 2a minus 2 is just 2a minus 2. That doesn't help you any. Okay? So normally we can't touch our variables in the same way that we would say, do what I'm going to do in green here, and subtract 3 from both sides. You can do that, okay? But there's no number on this right-hand side, so what you're really doing is subtracting 3 from 0, because you have 3a plus 0. You take away 3 from both sides. That doesn't help you either, really. So let's not worry about any of the things that we just tried to do. I'm just showing you what we cannot do up until now. I'm going to show you correctly a way that we can, right now, deal with variables on both sides. What I can do is I can look for, usually the smaller one is the one I want to talk about, and that's going to be the 2a here, right? What I want to do is I want to subtract it from both sides. What happens if I subtract this whole thing, 2a, from both sides? I'll do it both sides. And once again, as always, do not forget to write what you're actually doing, this minus sign. A lot of students want to just leave the sign off, and then they end up making very easy and simple mistakes because they're not actually writing what they're doing. Now let's get back to it. What happens when I do 2a minus 2a? Okay, what does that give me? Well, 2a's take away 2a's from kindergarten. You should remember that anything take away itself is just 0. So I have crossed out a variable term on the left-hand side. Now the variable term will only show up on the right-hand side. Everything else stays the same. So I have this plus 3, that stays there. 3, or positive 3, equals whatever you have left over here. What do you have left here, though? 3a take away 2a. These are like terms, so I can combine them. 3a's take away 2a's is 1a, or more simply put, 3 is equal to a. Or if you prefer, a equals 3. They both mean exactly the same thing. It's just two ways of writing the same thing. This is what we have to do in order to solve equations where variables show up on both sides. You have to treat them just like we've been treating numbers, really, in that you have to subtract the whole thing, or if you had a negative to start with, you had to add the whole thing. Basically, undo the whole thing from both sides. That way, you will end up combining terms on combining like terms on one side, and you'll eliminate the term from the other side. Okay? Let's do another example real quick. Okay. I have this 3v minus 8 equals 7 plus 8v. Well, once again, I've got these variables on both sides. I can't deal with that. Okay? But what I can do, I can look at what I'm normally going to do is look for the smaller one. That's 3v here. And what I'm going to do is I'm going to get rid of 3v by subtracting it. I subtract it because I had a positive to start with, and when I subtract it, it gives me 0. But I have to do it on both sides of the equal sign, and I find my term that has a v, and I will subtract the 3v from there as well. Okay? So, what do we get when we do all this? Well, this minus 8 drops back down. That's the only thing left on the left. Negative 8 equals 7. What's 8 minus 3? Plus 5v. Now we have a simple two-step equation. What I am going to do is I am going to subtract 7 from both sides. Subtract 7. And let's see what I get. What's negative 8 minus 7? Well, that's negative 15. I get negative 15 equals, what's left on the other side? Just 5v, positive 5v. And now what I'm going to do, I'm going to divide 5 from both sides to get v by itself. Divide by 5. Negative 15 divided by 5 is negative 3, and that's what v equals. That's it. You are done. The only thing you have to remember is that when you have variables on both sides, you have to get rid of them from one side by subtracting, or in the case, very quickly, in the case of something like this, if you had negative 2v plus 1 equals negative 3v, and you wanted the v gone from one of the sides, what you would do is, because you had a negative 2 here, to undo a negative 2v, you would add 2v, and then solve from there. 1 equals negative 1v, and you would get that v equals negative 1. Okay? So you just have to, it's basically the same as what we've been doing with numbers all along. You have to undo the operation in order to get rid of it. Okay? So here are some that you can try on your own. 6x plus 3 equals x plus 8. You will have to get rid of a variable from one side. On number 1, same thing on number 2. I need you to try those on your own. Now, number 2, solving multi-step equations with variables on both sides. Okay, so things get a little bit more complicated. As you can see, we have the distributive property over here. Anytime you have a number times something in parentheses, it tells me, let's do the distributive property, where you have 4 times x and 4 times negative 5. Okay, and then we have some other stuff here. We have, in A, we have combining like terms before we see that we have variables on both sides. So the rule of thumb, very, very important, is simplify each side of an equal sign. Before doing anything else. This works almost all the time. Okay, so you want to make sure that you simplify each side of an equal sign before doing anything else. Well, what does that mean? That means we're going to look at this side here and we're going to see, can I simplify this by itself any before I try to do anything else? Same thing over here. Can I simplify this any before I try to do anything else? And the answer to both of those questions is yes, I can. On the left-hand side, I have 2c, 3c, and I'm going to definitely simplify those. 2c take away 3c, It's going to be negative 1c, or just negative c. And the plus 4 stays the same. And then on the right-hand side, this negative 9 plus 5. That's going to simplify to negative 4. And then the plus c stays. Now I cannot simplify anymore, because if I look at the left-hand side here, these are not like terms. If I look at the right-hand side here, these are not like terms. So I cannot simplify anymore, but what I can do now is I can start, first of all, I notice I've got a variable on both sides. I don't like it when that happens, so I want to get rid of it from one side. And the side that you usually want to try to get rid of it from is the smaller side. The smaller number here is negative 1. Okay, so I'm going to get rid of negative 1c by adding 1c to both sides. Those add up to 0. And then I will add 1c over here. Always make sure that when you're adding terms on both sides, you do it with like terms. So you would not add this 1c to the negative 4. That doesn't make sense. You would add it to the 1c. Okay? Okay, so on the left-hand side, we have 4 is equal to. On the right-hand side, we have negative 4, and then c plus 1c. That's going to give me 2c, plus 2c. Now I have a regular two-step equation, or multi-step equation. Sorry, no, it's a two-step equation. I will add 4 to both sides. I will get 8 equals 2c. And then very easily I will say divide by 2, and I get 4 equals c, or c equals 4, either way you prefer. I'm going to move that down so that we can do the next question. Anytime I see that I have a distributive property thing I can do here, I will go ahead and do it first. 4 times x. 4 times negative 5. Not 4 times 5. 4 times negative 5. Okay? And this will give me 4x is 4 times x. And then 4 times negative 5 is negative 20, minus 20. 4x minus 20, and then I will bring everything else down. Minus 5. Okay? And that's going to equal, well, while I'm doing this, let me see if I can combine any like terms and save myself a step. 6x minus 4x, well, that's 2x. So I'm going to write 2x plus 7.4. And don't everybody go nuts because there's a decimal. Oh, well, it happens. Okay? Now what I want to do is, once again, as we wrote down here, okay? Simplify each side of an equal sign before doing anything else. So I want to make sure that I can simplify each side here as much as possible. So I look for like terms. Negative 20 minus 5. Those are like terms. It comes out to negative 25. Over on the right-hand side, I have no like terms, so I can't do anything. I bring everything else down. 4x minus 25 equals 2x plus 7.4. Now I notice that, hey, I've got variables on both sides. I don't like it when that happens, so I'm going to subtract the smaller one, or get rid of the smaller one, which it happens to be 2x. So minus 2x. Minus 2x. This gives me 2x here. This one gives me 0, so I have 2x minus 25 equals 7.4. Going to give myself a little bit more room. Okay. And I'm going to look at the equation that I have right here. 2x minus 25 equals 7.4. And so I will do something to both sides, and what I'm going to do is add 25 to both sides. I'm going to wind up with 2x equals, well, these 25s are gone, so 7.4 plus 25, that's going to give me 32.4. Now all I have to do is divide both sides by 2. I divide by 2 here. I divide by 2 here. 32 divided by 2 is 16, so I get x equals 16. 0.4 divided by 2 is 0.2, so 16.2, and I am done. So, the big sum up thing, what you need to do is simplify each side of an equal sign before doing anything else. That's very, very important. And then we can go ahead and do what we have been doing, is getting the variables to only one side. So once we have simplified each side separately, we're going to get the variables to only one side and then solve like normal. Here's a couple of questions you can work on your own. Okay, this one obviously is going to need the distributive property. This one up here is going to need you to simplify some stuff, and then get the variables to only one side. They're both going to require you to get the variables to one side. Okay, so those are for you to work on, and I am moving on. And here is a little note about what happens when screwiness happens. Once we have variables on both sides, we allow for a screwy factor. Okay, what does that mean? Well, let's look at A right here and see what happens when we try to do this. When we say with A, hey, I've got variables on both sides, I can't simplify either side more, so let me start getting rid of this. I want to look for the smaller one. Well, they're actually the same, so I get to pick whichever one I want. I'll pick the one on the left. I want to get rid of the left by subtracting G. That adds up to 0. So I have to do the same thing to the right. Well, what's G minus G? Well, that's also 0. So let's bring down what we have left. 7 equals -3. There is no variable left. It has fallen out. They have canceled out completely. No variable left. I have a statement saying 7 equals -3. Well, this is false. So what this statement is, what this equation up here is actually saying is some number plus 7 equals that same number plus minus 3, which can absolutely never happen. What we have shown, when you get something screwy like this, a statement without variables that you know is false, what you write is that there is no solution. And what that means is that there is no value of G that would make this true. Let me erase this so I can show you what we're talking about here. There is no variable of G that would make this statement here true. It cannot actually work. Go ahead and try it with a couple of numbers. If you tried it with 1 plus 7 is 8. 1 minus 3 is -2. Try it with 100. 100 plus 7, 100 minus 3. 107 is not equal to 97. You will always be off because this statement cannot actually happen. You can't take the same number on both sides. You can't start with the same number, add 7 to one side, take away 3 from the other side, and get something that equals each other. So there is no solution. Anytime you wind up with something that's clearly false, some number equals a different number, then there is no value that we can pick for the variable that would make this statement true. Okay? Let's try another example, maybe make it a little clearer. If we had 4f minus 8 equals 4f minus 8, well, once again, we need to get rid of the variable from one side because we have a variable on both sides here. Okay? So what I am going to do is I am going to take 4f from one side. That adds up to 0. I'm going to take 4f from the other side. That adds up to 0. What am I left with? -8 equals -8. Once again, we are left with no variables, just a statement that has numbers. This case, -8 equals -8, this one's true. What this means is that no matter what you pick for your variable, you will always get a true statement. Okay? So what you get here is that -8 equals -8, and so what we say is instead of no solutions, we write all solutions, because this means whatever you pick for your variable, you could pick -1 million, you can pick 4.6, you can pick any number, any number at all, you will always get a true statement. Okay? So whatever you pick for f will be true, so we write all solutions. Any value for x would be absolutely true. Let's do the last two very quickly. We have the distributive property, 5h, 5 times negative 1, so we get 5h minus 5 equals negative 5 plus 5h. And notice I have variables on both sides, so I will take 5h from this side, I will take 5h from this side. They both give me 0, and I wind up with negative 5 equals negative 5.
Captain in Baskerville, please report to the main office.
And once again, I have a true statement, and a true statement means all solutions are valid. Okay? And finally, letter D, distributive property again, 3 times 4x, 3 times 2, I get 12x plus 6 equals 12x, and I am going to do the same thing. I got to get rid of this 12x from one side, get rid of the 12x from the other. They both give me 0, and I'm left with 6 equals, well, nothing. So we write 6 equals 0. Clearly false. So there is no solution that would make this true. No value we can pick for the variable that fits this. Okay? That's all there is to it. If you get a statement like this that says negative 5 equals negative 5, something that's true, then you write all solutions. If you get something that's clearly false, 6 equals 0, then there are no solutions. Okay? And here's a couple of your turn questions. Remember, if you can do the starred ones that we have throughout the video, you should be fine on doing the CV for next class. All right, thanks a lot. That's all there is to it. Feel free to watch again if you have questions. Thanks a lot.